Monitoring neuromuscular blockade. Following emergence from anaesthesia, inadequate reversal of neuromuscular blockade should be suspected if the patient appears weak. This may manifest as a poorly sustained grip or inability to sustain head lift, or if they display characteristic jerky movements and poor respiratory effort. Routine use of neuromuscular junction monitoring should avoid this situation. NMJ monitoring involves supramaximal stimulation of a peripheral nerve with observation or quantitative measurement of muscle contraction. Common monitoring sites are the ulnar nerve at the wrist, observing contraction of adductor pollicis brevis, and the facial nerve, observing contraction of orbicularis oculi. For monitoring the neuromuscular junction at the ulnar nerve, first place the cathode, which is the black electrode, distally at the head of the ulna. The nerve is superficial here. Place the anode 2.5 centimeters away, proximally, and preferably not in the path of the ulnar nerve. Third, apply a supramaximal current, about 50 to 60 milliamps, in a train of 4 pattern. The train of 4 involves 4 pulses of current, each 0.5 seconds apart, that is a frequency of 2 Hz. As you're doing this, either observe or measure where there's any decrease or fade in the force of contraction over the course of the 4 twitches. Here is what you might expect to see. If there's no residual blockade or you haven't given any muscle relaxant, there's no fade in twitch amplitude over the course of the 4 twitches. The 4th twitch T4 has the same magnitude as the first twitch T1, so the ratio T4 to T1 is 1. In this second pattern, there's deep, complete neuromuscular block and no twitches are detectable at all. In this pattern, there is significant residual neuromuscular block. Twitch amplitude reduces sequentially from T1 to 4, with each successive muscle contraction weaker than the one preceding. In this instance, the force of contraction after the 4th impulse is 30% of the force of contraction of the first impulse, giving a T4 to T1 ratio of 0.3. If you're observing rather than measuring force of contraction, all you really can say is that there's no fade, or minimal fade, or marked fade, or no twitch response at all to give you an indication of how profound the residual block is. Visual and tactile evaluation of fade is unreliable. It's been shown to be difficult to detect fade at all if the ratio of T4 to T1 is more than 40%. There's also the question of what train of 4 ratio is safe, i.e. at what point would you not feel it necessary to reverse further. And it may be that a T4-T1 ratio of 0.9 is still demonstrating significant muscle weakness. Other patterns of neuromuscular junction stimulation may be more likely to detect fade. Double burst stimulation is the most popular of these, but the popularity of train of 4 has never really waned. The RCOA and the Association of Anaesthetists recommend quantitative monitoring as standard rather than visual or tactile, and I'll discuss this a bit. There are 3 modes of quantitative analysis of muscle force of contraction. There's mechanomyography, electromyography, and acceleromyography. The only one in routine clinical use is AMG, and it's the only one I'll describe. Acceleromyography measures the acceleration of a contracting muscle, in this case the adductor pollicis. The acceleration is directly proportional to the force of contraction. A sensor is strapped to the thumb, which produces a voltage when the thumb moves, which is proportional to the acceleration of the thumb. This is then converted to an electrical signal, which is displayed as twitch response, and the T4 to T1 ratio can be calculated. The example shown in the picture is the train of 4 watch or TOF watch made by Organon, and it's a commonly used acceleromyography device.